Please stop the humming. I have to say that every day. Really? Okay, so we've gone over multiple questions through this module, and we're actually supposed to go over the driving question board. I'll go over the questions from it. We've talked about what is energy, how does energy transfer from place to place, how does energy transform. We talked about how energy transferred from place to place yesterday, didn't we? You had that in that answer on page 1, right? You're supposed to anyway. If you didn't, I took off the point. You're supposed to talk about how energy transforms in your answer yesterday, as well as at lesson 10. And if you didn't, I took off points again, right? Those were our 3 big questions that we've talked about. In fact, our focus question, the last one we had, the thing in yellow up there on the board, is how does energy transform? Okay. We were supposed to spend 30 minutes going over all our little questions on the driving question board. But knowing what your conceptual checkpoint question is and knowing what your module assessment questions are, spending 30 minutes going over the driving question board, it's not going to help you. So that's a waste of your time. A better use of your time is going over the actual questions on your test. So are y'all cool with doing that? So you see where learn is blank beside it up there on the agenda? That's where I erase driving question board, because I'm not going to waste your time. Okay. You guys know how much we rush in here to get everything covered. I'm going to use your time most efficiently. So I dropped the 30-minute study in the question board, not wasting your time. Okay. So the next thing is revisit the boy who harnessed the wind. This part is a very good use of time. William, and again, I apologize in advance for massacring his name, Kakwamba, he's the young man who lived in Malawi in Africa, who wanted to bring running water to his desperately poor village. Remember, his village didn't have water. And what was going on in his village, guys?
A drought.
A drought. And what was the drought causing?
Less food.
A lot less food. And people couldn't go to school anymore because they didn't have money to afford the private school there, right? Because they don't have free public education like we do here. Everybody has to pay for school there. So they couldn't go to school anymore, including William. And so he had to sneak onto the school grounds to get to the library to learn about making what? A windmill. So he learned how to build a windmill in order to do what? What did he want to do with the windmill? Was it to build light? Make light? No. What was the first thing he used it to do? You recall? Melanie. Well, that was his ultimate goal, was to get water. But do you remember the first thing he did, Ricardo?
Harvest the wind.
That was the ultimate goal, was harvesting the wind, and that's the name of the book. But did we learn about him listening to music on this first page? Okay. So let me back up a little bit to their big question, because remember, we always have bigger questions and then we have more focused questions, right? Because that is ultimately what science is about. I need y'all to stop sketching. So pay attention to the lesson. Okay. How could our knowledge of energy help us make the world better? And it's the whole reason this curriculum has me teaching you about energy. How could our knowledge, specifically your knowledge of energy, help make the world better? Because I'm halfway through my life. You're not. You're just beginning yours. How could your knowledge of energy help make the world better? Megan, feel free to jump in here because everybody's been quiet. Good morning, Colby. Did you already have your temp taken?
Yeah, I give my slip to Miss.
Daniels, fabulous. I love you taking the initiative yourself. Fabulous. Just make sure no cord gets shut in there. That's what I always have to watch for. Think back when we covered module 1. Did we talk about alternative energies? Hello, hello? Anyone in the classroom?
Yes.
Yes? Okay. So how could our knowledge of energy help make the world better? Do we have to use gasoline?
No.
Well, I mean, I have to technically in my car right now, but what about the future? No. What else can we do? What else have we learned about? What did we see yesterday in the photo? Come on in, Mariah. Have you had your temp taken? Excuse me for a moment, guys. I haven't done attendance yet either, so you're not officially late here. Go through the office. Yes, ma'am. Yeah. Okay. Well, I have to look at this. On my end, they're not like that. 968. What number are you 10? Come on, guys, I gotta have some answers from y'all. I don't bite. Not much of my lunch. What can be used? How can our knowledge of energy help us for the future? Specifically for the future of our Earth.
We could make it safer, like for the plants and environment. We can make energy out of
What?
water and
Yes,
wind.
we could use hydroelectricity. We could use electricity from wind because we could use energy of what? Energy of
Movement.
energy of movement.
I said
Because we would be using what thing that we talked about the past 2 days? Nope. What thing did we talk about the last 2 days?
Energy.
Nope. The thing that I just built with my son.
Generators.
Generators.
We can make eco-friendly generators.
We can make eco-friendly generators. They're going to take either wind, like a windmill does, or hydroelectricity, and use those two things that involve movement of something that's coming from the environment, and it moves the magnets inside the generator and then transfers the energy through wires, right?
Mm-hmm.
And then it can be used to power our devices. Make sense?
Like it powered the light.
Like it powered the light. It could also be used to power something else. What else could it be used to power?
It could be used to like.
Maybe Colby's here. Hold on. It's hard doing attendance and teaching at the same time. Okay. 1, 2, 3. 15. Oop, a little late on attendance, but oh well. At least it's done. I didn't do attendance at 11 a.m. That's an improvement. Okay, so we could use a generator plus things like wind or water to have eco-friendly power, right? What else could we do in our home already? What can we do right now using, you know, the coal-driven power that we have right now? I do things every night before I leave this classroom. Michaela.
One thing to save energy would be like turning off the lights every time you leave.
Correct. Turn off your lights when you leave the room. Every time I leave for the end of the day, I turn off my projector because that bulb has a limited life. And the light bulb in that thing costs almost as much as the projector itself. The light bulb's over $100. Isn't that crazy? Again, it's the school vendor. Trust me. I turn this off. I turn that off. I turn the overhead lights off. And even though I only keep one strip on because of my migraines, it also saves a lot of energy only using one strip instead of the 3.
Put a brick on the toilet.
No.
What? That saves water.
But no, putting a brick in the toilet doesn't save water. But think about something that modern toilets do have that is energy efficient. School toilets don't have them, but your homes probably do. A lot of businesses don't tend to have this, but your home toilets do. They're energy efficient. How? How are they efficient? You guys aren't plumbers, so you wouldn't know this, and you're not the one going to the store to buy them. So, Melanie. You gotta speak up a little bit.
But in places they have the stranger uses
No, not at all.
So toilets now, not in commercial buildings for the most part, especially not in school buildings because these are old. They're water efficient. They use a lot less water. Now these school toilets, you flush and it seems to flush forever, doesn't it? It uses a lot of water. All right. The toilets you have at home, if they're newer than like 12 years, 15 years, they're going to be energy efficient. They're water efficient. They use a lot less water. Okay. A lot of your showers are also going to be energy efficient. They're going to use a lot less water. A lot less water. Your sinks might have something that slows down the speed that the water comes out of the sink. It might even have something called an aerator on it to push air out with the water so that it feels like you have more water coming out at one time than you do. That way, you're not using up as much water at a time. And it will tell you how many gallons are coming out of your sink at a time so that you can compare one sink to another and you can go with a more energy efficient model. Okay. What else can a person do to make the world better?
Something.
Or make yourself safer? This is one I would not have thought of. It says on here, I could be more careful when I ride my bike fast. Since I'm going fast, the bike and I have a lot of energy. And if I'm in a collision, I could hurt someone. Yes, that would be the someone. Yourself. You hit a curb, ouch. Who in here has ridden their bike on a Shreveport sidewalk?
No.
Or walked on a Shreveport sidewalk? They're not so smooth, are they?
I rode it on the road before.
Good chance you're gonna hit a bad spot and go flying, right? Really good chance. No, but you're gonna be hurt and bleeding. Possibly in the road, which would be really bad. Cars. Because not everybody drives real well. And not everybody pays attention when they're driving. You might pay attention on a bike because you're on the small thing. But people in a car don't always pay attention.
No, they talk on the phone all the time.
Or they're doing other things they shouldn't be doing while driving. Yes, ma'am.
When I'm at Man's house and we ride out on the bikes that they have in the shed. Me and David and my brothers in winter ride down the road, and we normally ride on a bunch of speed bumps.
That doesn't sound so good for the head anyway. What about in the future? Do you think, since you guys, you are the future,
We are.
you are. In 5 to 6 years, you're going to be getting your driver's permits.
Then 16. Well, like 15.
No, 5 to 6 years, you're going to be getting your driver's permits. In 8 years, odds are good that you're going to be driving every day. Guys, quiet. In 10 to 12 years, you'll be buying your first car that you're buying on your own. That's not that far away.
Yeah.
So in that 10 to 12 years, you'll be making decisions about what kind of cars are the popular ones to buy.
No.
Is it going to be the big SUVs that suck down energy, aka oil? Or is it going to be electric powered cars that only go a short distance? Or are you guys going to, and when I say money talks, the cars that sell most are the ones that the car makers are going to sell more of, and they're going to make more of to meet the demand. Or are you going to buy the cars that are electric powered, or maybe some kind of other alternative fuel powered that go farther? What you buy a lot of is what the car makers are going to make a lot of. Your money and your decisions affect what is made. So when you grow up and you start making money and buying big purchases like that, your decisions influence what society makes.
Yeah,
You hadn't thought about that, right? So what I teach you now and what you learn in school influences what you do as a young adult.
When I was a kid, I wanted this yellow truck. And
Oh, he wants an orange car.
Okay.
Okay.
That yellow truck.
So fabulous. It wants me to go through and count the pages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
On a diesel truck.
13, 14, 15. Did we read this page with, of course, this doesn't back up. Okay, Logan. Guys, do you remember if we read the part where he climbed up and actually got the blades to go in?
No.
All right, so I shall back up. I do remember reading this where he was chopping at the tree to get the wood. Okay, so I'll start on this page. His cousin Jeffrey and best friend Gilbert soon appeared. Muli Buangji, they greeted. Can we help with electric wind? Grab your pangas and follow me, he said, and took them into the forest. Together they wrung their sharp blades into the trunks of blue gum trees, then hammered them together to make the tower. Standing atop, William shouted, "Bring it up," while the boys tugged and heaved. I do not like this glare on this book. Okay, that's a little better. Hold on, guys. Logan. All right, that got rid of the glare, right? Standing atop, William shouted. For a moment it did. William shouted, "Bring it up," while the boys tugged and heaved. A crowd gathered below and gazed at this strange machine that now leaned and wobbled like a clumsy giraffe. Some giggled, others teased, but William waited for the wind. His gangly windmill. Like always, it came. First a breeze, then a gusting gale. The tower swayed and the blades swung round. With sore hands, ugh, boy, that glare is bad. Once slowed by hunger and darkness, William connected wires to a small bulb, which flickered at first, then surged as bright as the sun. Tonga, he shouted, I have made electric wind. Oh, wow. I'm going to kill that word. Watch it to Wimbo, a man yelled. Well done. As the doubters clapped and cheered, William knew he had just begun. Light could not fill empty bellies, but another windmill could soak the dry ground, creating food where once there was none. Magetsi Amapepo, electric wind, can fill my country, William thought. And that was the strongest magic of all. Why is the ground all green?
Because they blasted
Because what?
because they went
It's drenched by water.
It's drenched by water because what do the windmills do?
made me like
They didn't make water, but what do?
they got
They soak the ground because the generators where they used to make light, they were used to pump water, which is actually what your conceptual checkpoint is today.
really
I said it yesterday, and I said it in the video Monday. Okay, so the ground is soaked, and again, it is ready and fertile for growing plants. Okay, and here's a picture of his actual windmill. Just as janky looking as possible, but it was functional.
he actually made that.
Yes. Did not look pretty, but it worked.
Look,
Janky. Okay.
not gonna do it.
All right. What problems did William hope to solve by building a windmill?
Just to soak the ground with water to have plants to feed their families with.
Exactly, Megan. People were starving. He wanted to fill their bellies with food. And the way to do that was to make the ground wet so they could grow crops.
So I wanted to go to school.
And then they'd be able to afford to go to school and be able to afford to have money to do a lot of the necessary things that they needed, right? So how could the windmill solve those problems?
It could like pump water.
It could pump water, right?
Yeah.
It made electricity, right? If he did it correctly.
But he did.
Okay. What steps did William take to build his windmill system, Kaylee?
Oh.
Look, I'm like William. I use a janky solution for making my book stand up and not have glare. Come on, sleepyhead. I made somebody in my second block yesterday stand so she can go to sleep. Do you need that solution? Okie doke. Okay, doke. Give me an answer. What steps did William take to build his windmill system? Hint, this will not be a step that you give me in your conceptual checkpoint because you're not going to go to the junkyard. We're not taking this trip to Pipe Shoe Pullet today.
Huh?
That's our nearest junkyard, is it not? Come on, Miss Wilson. You can't dial your brother. He's a little busy right now. No Dalton right now. I bet James would know. Edgel. Yes, I remember big siblings that I teach. I bet your big brother wouldn't remember that. He's in high school now, so he wouldn't remember. But James would. I've taught quite a few of my current students big siblings. And I remember big siblings. Yes, I've taught Innocente's big sibling. Yes, you're the oldest. You're the first. 4 more. There's only 4 y'all total. Come on. Poor Amber, when she comes up next year, she's gonna be number 3. Come on, give me an answer, Kaylee. What did William do? Did he go to the local Walmart to get his parts? No, where'd he go? Sky Eunice trying, and she wasn't even here for the whole book.
I wasn't even here for the book, and I want to listen.
Where'd he go? Did you go pipes you pull it for it? No, where'd he go?
He went around where he lives and found some random stuff that he could use.
Correct. He went to, they wrote it to a junkyard, but he went around just to find random parts, right?
And like this.
Yeah, I mean, if you need inspiration, there's the picture. A bike tire, scraps of wood, looks like fan blades. Nothing too fancy, right?
How does that even work?
Well, I can tell you for your big task in science, they wanted you to take that paper plate windmill you made, plus that janky generator that Colby and I made, and popsicle sticks and make you a windmill.
So we can make that.
I'm pretty certain that would fall apart and leave you so aggravated. So I said, scratch that. We save ourselves a week and a half.
We are aggravated.
And the other thing was some of you would have to bring in a generator from home. Michaela, stop distracting other people. Some of you would have to bring a generator from home. And yeah, I survived because generators off gas. So we would be, perishing from carbon monoxide poisoning in the classroom. I'd rather skip that fun.
Yeah,
That's an occasion where the people who made the curriculum weren't thinking through things. They weren't actual teachers in a classroom. I guess they thought our classroom was outside.
Bring a generator in the classroom. What?
Okay, so William went to various places and found just pieces. He found a broken bicycle and took off the parts he needed. He found a generator from a bike headlight. Good luck finding that. And I'm not going to ask my students to go to a junkyard and go find what you need. Parents really might not appreciate that field trip.
I would.
Who did he ask for help? His friends.
His friend.
Donna and Michelle.
What did he do to get the wood? Did he go to Home Depot?
No, he was
used
not
his friends to
He went to the
help
forest and
down
chopped down trees, right? You think your parents would be very happy if I told you to go do that? I'm thinking there'd be a big "what is wrong with your teacher" kind of moment, right? Universally, right? Yeah. Again, this project, no. And before he used it to pump water, what was the first thing he made? What was the first thing he did as an indicator of energy flowing through his windmill.
I have the answer to something.
He used the light and he plugged it into the light.
Yes, he used it to make a light bulb light up, right?
Yeah.
Which is what we did with our windmill system, right?
Okay.
Okay, so the illustrations on page 22 and 23. I love how they don't number any of these pages, but they want me to just automatically know what page numbers these are. It's great. How do these tell us energy is transferring? The blue, what does that blue represent? Wind, which is exactly what I used in my illustration, right?
Fan.
Yeah, to show the fan was blowing the wind, right? All right. What is this supposed to show?
A light bulb.
The light bulb.
But this reminds you, because it's the same pattern, of this, right? So this is supposed to tell you that what is around the light. Not necessarily wind, but just in general what? Energy.
Air.
Well, not air. It does look like air because of blue, but it's supposed to tell us it's energy and it's different. So it's in a different pattern. It's not like this. So it is transformed. That's why they put it in a different pattern. Okay. I need my friends at table 3 to make sure they're paying attention. Okay. So this picture is supposed to show us transform. All right. And this is again supposed to show us energy in the form of what? Wind. And the fact that it's going through the blades is just showing us it's capturing in the wind blades, the windmill blades. Okay. Wow, they really get into this. It says the first picture shows the energy is transferred from the wind to the windmill, where the blue lines wrap around the blades. And then the next page shows wire transfers energy from the windmill to the light bulb.
I don't think Joanna heard that.
Yeah, me neither.
Joanna.
Joanna.
Okay.
Oh.
Hello. Wakey, wakey. Okay. Sit up. That's supposed to be energy transferring to the light bulb. From the windmill to light bulb. Holy moly. They got a lot of detail on this one. This shows motion energy transforming into light. It only shows blue lines for wind and yellow for the light, but we know there's probably a generator between the blades and the light bulb that transforms the energy. Wow. That's really putting a lot of interpretation in that picture. Ooh. Okay, so you guys have heard me describe my son like this. So Kayla, a lot of drawing going on over there. I really hope you're paying attention. William was a very good builder, right? And he was very good at taking ideas and turning them into building things, to ideas, to creations, right? Who else have I described like that? Who's good at science? Colby. So that term is an engineer. Someone who's good at taking ideas and turning them into something built. And that's what science, they want, PhD wants our little science people to be. Engineers. People who can think through a problem and solve the problem to create a solution. That's what engineers do. That's why they have you drawing all these things and then explaining it so you can come up with your solution. Okay, that's what engineers do. All right. I'm going to show you this. I'm going to explain what I need to see for an answer. I normally don't do all this. Then, and keep your pencils down, because I'm going to give you the answer. Hunter, sit up.
I'll sit on my feet.
I'm going to give you the answer. And then I'm going to turn you loose to actually write it. Clear? I put this in a video yesterday. All right. A woman in a neighboring village heard about William Kakwamba and what he did to transform wind energy into electrical energy. She is excited at the idea of using electricity to pump water. Develop an explanation for how this woman can use a windmill to turn on a water pump and provide enough water for her family. Apply all the knowledge from the key concepts checklist. So yesterday, page 43. No, 43. You had a key concepts checklist. Energy transformations, energy transfers, relationship between energy and speed. Indicators of energy, you really, if you add that in there, great, but that one's not as important as everything else. You need to describe the transformations, energy transfers, and relationship between energy and speed. Sorry, I'm boring you, Sky. All right, here's a perfect answer. I've actually got 2 perfect answers for you to choose from. I've already written it out for you and everything. I'm visual. You guys can look around my classroom and tell that, right? I can say it, but it's a lot easier for a lot of people if you can read it and hear it at the same time. Okay? This answer, I'm telling you right now, you write that last sentence on there, I might just give you a bonus point. How often do I give bonus points in my classes? This 9 weeks, I gave you bonus points once on social studies, and I'm giving you an opportunity to get a bonus point on this conceptual checkpoint and an opportunity to get 5 bonus points on your test tomorrow, because your test tomorrow is very hard. No, that's cheating. Put your pencil down. All right, here's a perfect answer. The woman can use a windmill to turn on a water pump. First of all, took the question and turned it into a statement. Just like we're writing a paragraph, right? First, wind colliding. We took that term that we talked about before, right? Wind colliding with the windmill blades would cause the blades to spin. Then that would cause the generator's magnets to spin, transforming. There's that word that I said I needed to see. Transforming into electrical energy. This electrical energy would transfer, there's that other word I need to see, through wires from the generator to a water pump. I mentioned that generator that we talked about yesterday. Okay, I hope you're paying attention, baby. In this way, a windmill could be used. Get all those interruptions. In this way, a windmill could be used to power a water pump. The faster the blades spin, the more energy of motion they have. So they would pump water faster. That is given the relationship between speed and energy. That's that 3rd key concept. Then that last sentence gives us evidence, and that's where your bonus point comes in. I know this because in the windmill model, the light is brighter when there is more wind. Okay, that's one perfect answer with a bonus point possible. Got it? I'll show you another perfect answer. Okay. The woman can use a windmill to turn on a water pump. First, motion energy transfers from wind to the windmill, making the blades move. Then the generator transforms motion energy into electrical energy by producing an electric current. Next, the current transfers energy through the wires that connect the generator to the pump. That is how wind turns into electricity. When the blades spin faster, they have more energy of motion. This means there is more electrical energy being transferred to the pump, which would pump water faster. I know this because in the windmill model, the light is brighter when there is more wind. Those are 2 different perfect answers that will get you a bonus point. Got it? Everybody heard that, yes? All right, turn to page 47 in your notebook. Stop talking, because the more you talk, the more people forget the answer. Turn to page 47 in your notebook. There's your prompt. Answer it. Is that a little bit better, Joanna? Remember, you can look back at anything in your notebook that helps you. You can use my posters in my classroom, whatever you need. All these are resources to help you. When you finish, you can bring it back here to me, guys. But remember, there's quite a bit to the answer, okay? I do not want you rushing through it. No talking, please.
I'm done.
Okay. I still have some more teaching to go, so do not leave, okay? That's 3. What was that ringing sound? Oh, all right, I need Michaela seated. Who is still working on conceptual checkpoint? Okay. As soon as everybody is done with the conceptual checkpoint, guys, I'm gonna go ahead and finish up the land part, because there's 1 or 2 questions we need to go over. And then we're gonna go over every question of module assessment. I need time for us to go over module assessment. So I'm giving you guys 5 more minutes for conceptual checkpoint. So Megan, please do hang around, okay? Maya. You need to also get with someone, Maya, so you can get Monday's lesson done and Tuesday's lesson done. Today is Wednesday, yes. Hunter. Maya, you have your Chromebook, yes? So the lessons are video lessons. I would start, were you here Monday? So you have Monday's lesson already done, including front and back of the page? Okay. Go ahead and do, right now you have a couple minutes to start on yesterday's lesson. So go ahead and do that as well. Okay. All right, who is still working on their notebook right now? Okay. All right, so I have everybody's. Okay. What I'm gonna do is try to grade those during RTI time. I have everybody's notebooks already returned, right? Okay. So what I'm gonna do now is go over the land question. There's a couple of them. So if you're on your computer, if you could close it. I'm gonna go over the couple land questions. What are we like? 2. And then we're gonna go over the module assessment. There's only 4 questions, but each one of them has a lot to it. And they're hard. Logan, close it. That's why I put it on this question on the module assessment. Okay. I went and talked to the 5th grade science assistant from Smith, and she said the same thing. Our science assessments are hard because there's so much critical thinking to it. That's why I put your conceptual checkpoint that I just gave you the answers to right back on it as a bonus question. I've not given you a bonus question on the module assessment before. I never gave one last year either. This year I am, tomorrow I am, because this one's hard. It's only got 4 questions, but every question has so much to it. It's a lot tougher than the first one. Okay, so for your land, do you think windmills are a good way to generate electricity?
Yes.
Okay, but do you remember the windmill farms that we looked at early on in the module?
Yes.
Those great big windmills,
Yes.
the wind turbine farms. Where do they tend to put those most often?
Water.
Over the water, because why? Because what? Not to pump water. What do windmills require? No. Wind. And where is it windiest? Well, over what? Over water. You've been to the beach, right? I've got enough students who've been to the beach. It's windy at the beach. Okay. What do you recall that I told you about putting wind turbines in the ocean? What about the cost? Billions.
Ms. Baber,
Yes, ma'am.
do you have anything for those right here?
Yes, I do.
Okay, they're here.
Okay, let me send one down.
Ms. Remedios is sending something down also, so if y'all want to combine them.
Okay.
And I'm gonna check with Ms. Daniels.
Okay, thank you. No, I need you in here to touch me. Okay, so as I was saying, the cost of wind turbines over water, what about it? It's anywhere from hundreds of millions to billions of dollars for a whole farm of them, right? And what about their longevity over water? How long do those wind turbines last over water compared to their time of lasting over land? Do they last as long over water as they do over land? Because of storms, and also what else happens to the parts? Rust, because they're salt water, right? I mean, they're very effective over the ocean because there's so much wind, but they rust. But you balance that with wind turbines are clean energy, except that getting those parts out there require, because they're huge, big boats. What do those big boats run on? Diesel oil. Lots and lots and lots of diesel oil, which is not good for the environment. So getting those things put together out there uses up a lot of diesel oil. And the actual wind turbines require a good bit of motor oil up in on the inside to keep them going smoothly, to keep the fans going smoothly. They have to have no friction.
I would rather have a windmill than a wind turbine.
Wind turbines generate so much energy though. They're very effective. It's just that they also use oil, and people don't realize that. But they do generate a lot of electricity. You remember the numbers when we analyzed the numbers at the beginning? When we were in module 1, they generate a lot of electricity, a lot. So it's kind of a balance. You have positives and you have negatives with wind turbines. And the wind's going to blow anyway. So if we're not utilizing the energy, it's wasted energy. A hurricane. Okay. This right here, someone stated an opinion. I think there are better ways to generate electricity, like drilling or building a dam. But does putting in a dam affect the environment? It reroutes the river, which changes the entire habitat, doesn't it? Changes the animals and the plants, doesn't it? You can change it from a forested area to a desert in that local area, correct? You can totally change up your environment. What impacts do you think windmills can have on our environment?
Like oil and stuff?
You could, right, the oil, if it leaks out, could affect the animals or the water.
If the animals might.
What about the birds?
Oh,
The birds, it's a slaughter on birds, isn't it? Thankfully, we don't have turbines right here, so we don't see the bird slaughter, but birds flying to them. Birds flying to those blades. Wind turbines and birds are not friends. What about wind farms and trees? What do they have to do with the trees if they build a wind farm? Something, all right. What? They have to get rid of the trees. So they have to cut down trees to build a wind farm. So the animals that live in that forest have to relocate somewhere. So that can be an issue. So there are positives and negatives to windmill farms and wind turbine farms. All right. I need to get you guys to the test review. And remember, if we don't finish this, it's on Canvas already. Let me show you where it is on Canvas, okay? All right, I need the talking to stop. Oh, fabulous. It's not even showing up. Oh, that's why. Because all this stuff shut down. Because, you know, it's funsies. Mickey? I still hear talking. why. Okay, see this right here that's in red? It is dark, but do you see the red? That's what it is. Conceptual checkpoint and module 2 assessment review. Michaela, I need you paying attention. I've had to call your name multiple times today. That is where your test review is. If we don't get to finish this today, that's where you're going to find your review. Okay. I know it's conceptual checkpoint that we just finished, but that's your bonus points for the test anyway. Okay. Let me show this to Megan. Okay, Megan, this is where the review is, review video. Okay. All right. Let me switch share back to ImageMate. I'll probably take twice to get it shared correctly. All right, here's your first question on in the module assessment. Imagine you're in the kitchen helping to cook dinner and listening to music. Draw a model to show the indicators of energy that you would observe. Be sure to label your model, including the indicators of energy. I've got 2 different models for you. There's theirs. Okay, stove, and it shows the plug, and you need to label the plug. And it says electricity, and label the plug and electricity. Microwave, temperature change, something that shows me temperature change, and then label temperature change. Please stop talking. Lights, they have a ceiling fan in their room, so it says motion. It says in the prompt, you are in the kitchen cooking dinner, so you have to have a person in there. If you're cooking, I'm going to assume you're moving, so you need to show motion. Cooking, so there's a pan on there, show there's some heat coming out of it because you're cooking. Temperature change, I have it where the oven is going, so temperature change. They said there's music coming, so the easiest way, they have it on here is a radio, and then these little lines coming out with sound. All right, listen guys, Logan keeps on making comments that are off topic, but I need you paying attention to this so you can do okay on the test tomorrow. You need to draw these items that would be found in a kitchen, including the radio, because it says you're listening to music, and the person that's moving because you're in the kitchen cooking. Cooking means you're going to have temperature change, because technically what we're learning is temperature change is an indicator of energy, not necessarily heat, but temperature change. Okay. You need to show the plug and the cord that runs to it. Okay, that's their drawing. Here's my drawing. I drew my kitchen. Okay, my kitchen is a little more detailed. Upper cabinets, rope lights on the top with a cord, says electrical energy, and a plug. Look, I labeled every plug. Stove with the pan, temperature change. Stove is plugged in, plug. Lower cabinets, radio, plugged in, plug, 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 sound. Microwave, temperature change, because there's something cooking in it. See the little pan in there or bowl? Fridge, they didn't even have a fridge in their room. Fridge, didn't we say that temperature change is an indicator? Well, the fridge makes things cold. That's a temperature change. Ice maker, temperature change. Under cabinet lights, cord, plug. Upper cabinets, rope light on top, plugged in, plug, plug. Chandelier, lights, sink, plug, person walking, showing motion. All of that detail. It's not a pretty picture, but you can tell what's going on, and it's all labeled. It shows the indicators of energy. It shows what they're plugged into. It shows sound because it asks for a radio. It shows a person walking because the person's cooking. It shows the microwave going because we're cooking something. It shows the oven going because we're cooking something. See the change in temperature? Shows the stove going with the pan on it. Not the best pan, but hey, it's a pan. And it shows change in temperature. That's what the little waves coming out of it mean. And it shows a plug for every single thing that's plugged in. Got it? If you want to draw your kitchen, go ahead. I did. It did not take me that long, but I can tell and you can tell what that is, correct? I got a bunch of plugs in my room. There's like 18 to 24 plugs in my room. There's a bunch. It's a custom kitchen. There's actually 2 chandeliers. There's more cabinets than that by far. It's wraparound top and bottom cabinets, lights all over the place, and plugs all over the place. Okay, but you get the idea. And I included a sink because apparently that other person's kitchen doesn't have a fridge or a sink or a microwave. I don't know. They're apparently cooking on a Bunsen burner or something. I don't know. Okay, so make your kitchen realistic. Put yourself in it because you're supposed to be cooking in it. And it said you're supposed to have some music. So if you want to draw headphones on yourself, go ahead. I wouldn't put beats in your ear or the little wireless things in your ear because it's too hard to see because I'm supposed to see music. The other way you could show music is to do the little musical notes to denote music. Okay, so you could show that for music. Okay, but I need something that tells me sound is coming out, and you need to tell me sound. You need to label this with words that I can understand. And I've got a couple students who make it very hard for me to understand your words. Make sure I can understand your words. Clear? Make sure I can understand your picture too. All right, that's your number 1. That's 1. It's 9:30. Stop talking. We got to go. Number 2 says use a pencil or a highlighter. You're going to be using your pencil to analyze the data set below. I know you're not writing anything, Miss Maya. Use the data set, and your data set is 20 pieces of data. To answer the questions that follow, you're going to have 3 sets of questions. Sets. There's a lot of information you have to go through. Student A and student B are curious about who can kick a soccer ball into a goal with more energy. They know that a slower ball will take more time to reach the goal. The students take turns kicking the ball from the same location and timing how long it takes for the ball to reach the goal. Their data set is displayed in the table below. Student A, there's her times. I'm assuming her. I got more girls in my classes this year than boys, so I'm just assuming girl. There's the times for that student there. Here's the times for student B to reach the goal. If you look carefully, student A, trial 1 gets to the goal faster. Trial 2 gets to the goal faster. Trial 3 gets to the goal faster. Trial 4, student B gets it there faster. Trial 5 is a tie. Trial 6, student A gets it there faster. Trial 7, student A gets it there faster. Trial 8, student A gets it there faster. Trial 9 is a tie. Trial 10, student A gets it there faster. So when you get to letter A, What patterns do you notice in the data set? Use evidence from the data to support your response. There. Pattern I see is a student A almost always kick the ball into the goal faster. Faster 7 times than student B. Student B kicked it faster only once. Then these times were averaged. I'm going to show you how to average this without using a calculator. Okay, so look. No, look, take the whole numbers and add them up. So 4 plus 4 is 8. Add the next 4. That's 12, right? So I put pluses to tell myself that I've added them up together. Okay, that's my sign that I've added those 3. Got it? 12 plus 5 is 17, right? So that plus means I've added those, and I'm going to erase this 12 to remind myself that I've already used that number. Okay, we good so far? I got 4.5 and another 4.5. So 4.5 and 4.5, y'all know what that is? What's half and half? A whole. So what's 4 and 4? 8. So what's 8 plus 1? 9. So 4.5 plus 4.5 is 9. 17 plus 9 is what? No. 26. So now I have those 2 numbers added up. Okay, so 4.5 and 4.5 is another 9. So 26 plus another 9 is 35. You know the fast way to add that? 9 is just 1 less than 10. So 26 plus 10 is 36. Take off 1, 35. That's how I always do it in my head. Did y'all hear me? You know how to add 10 to every number, right?
Yeah.
Then take off 1. So if you have 26 plus 9, in your head you'd say plus 10 is 36, take off 1, 35.
That's all I do.
Okay, so now we've added all these numbers, that's 35. Now we just have to add 5.5 and 4.5. Well, half and half's a whole. And then 5 and 4 is 9. So 9 plus 1 is 10. So 35 plus 10 more is 45. Okay. Did y'all see how I got all those numbers together? And I did it mental math without having to draw and do all the written numbers. Did it in my head.
Sure.
Does everybody see how I got that? Just mental math. Now watch this. We're dividing that number by 10. All I do is move my decimal point over. 4.5. That's the average. That's a really easy thing to do. And you didn't have to do any division. You didn't have to do any multiplication.
Okay, I remember.
It's really easy. Okay. All right. So let's look at this one. 6 and 5 is what? 11. 4 and 5 is what? 9. So 11 plus 9 is, okay. I'm going to erase the 11 so I don't forget that I've already done that. Okay. 5 and 5 is what? Plus another 5 is, so 15 plus 20 is what?
35.
Okay. So we got 35 so far. I haven't added anything with those point things yet, but now we're going to go back and do those. 5.5 and 5.5. What's 5 plus 5? plus that 0.5 and 0.5 makes one whole, so 11. So 35 plus 11 more is 46. So let me do, so I got 46. 46 plus 5.5 is
31, I mean, 51.
51.5. Let me make sure I added everything in. Okay, so should be 55. If I had added it correctly, it would have been 55. I did some math somewhere wrong because this answer should be 55. I did my math wrong, guys. Should be 55. That's what it should come out to. 11 plus 4 is 15. 20, 25, 30, 35. Did I say that was, hold on. 11, 11, 15, 20, 25, 30, 35. And 35. 46. I don't know why it's coming out wrong. Should be 51.5, but the average should come out as 5.5. What if?
These are the hardest questions ever, especially drawing the micro.
Okay. Sorry, I had to respond to the other teachers. Yeah, they did their math wrong. It's 51.5. They did it wrong. We did it right today.
5.15.
Yeah.
There you go. We were both wrong.
We were right today. Okay, so our average is 5.15. This is wrong down here.
5.15.
So this answer, the pattern I see is a student A almost always kicked the ball into the goal faster. I noticed a student A kicked the soccer ball in the goal faster 7 times. Student B kicked it faster only once. The average time for student A was 4.5 seconds. The average time for student B was 5.15 because it's when you add those all up, it's 51.5 seconds. You move that decimal place over one spot. Okay. That's analyzing your data. All right. Second question. And we're going to continue this during RTI. Do I have any students who go somewhere else for RTI today?
Miss Doty.
Okay. Y'all need to go on Canvas because I have that review thing on Canvas. Okay. Neither student has ever worked with this type of information before. What 3 questions might the students have about this data as they try to figure out who kicked the soccer ball with more energy? There are the 3 questions. Why did student B's soccer ball get to the goal faster in trial 4? Remember that one kick where student B's ball got there faster? It got there in 4 seconds. And student A's ball got there in 4.5 seconds. Then a follow-up question to that. Did student B use more energy when kicking the ball in trial 4? third question. How does the time needed for the ball to reach the goal relate to the amount of energy used to kick it? Does this remind you of the time that Allie and Innocente ran in the desk, bringing the energy to the desk?
No.
All right. Question or prompt C. Student A says she used more energy during the investigation than student B. Is there evidence in the data to support her claim? Yes. Since student A's soccer ball reached the goal faster than student B's ball in seven of the 10 trials, and the average time for student A was less than the average time for student B, student A used more energy. Student A transferred energy to the ball each time she kicked it. So she used more energy during the investigation. Okay. Still had 2 more questions to go. So we still have half the test to go. 4 questions plus that bonus. Let's line up. You have your library book, grab it.
Like, honey, but we were talking about this book right here.
Hold on just a second.